In this unit, we introduced the concept of enantiomers using molecular models, and now would be a great time if you have a molecular model kit to get out that kit and build a chiral carbon that has 4 different groups attached to it. So a chiral carbon by definition is a carbon atom, which will be black in your kit, and that carbon atom you should connect to 4 different groups. And I'm illustrating the 4 different groups in my molecular models just using different colored atoms. So white, red, orange, and green. You can use whatever 4 colors you want, or you could attach much more massive groups here. It doesn't matter. I'm just trying to make a simplified illustration here by using different colors to represent the 4 different groups that are bonded to this carbon. So the carbon atom that we have here in black, we would definitely define as a chiral carbon because it has 4 different groups bonded to it. On the other hand, on the right side here, I have an additional molecule that also has a chiral carbon. So this is our chiral carbon here, and it has the same 4 groups bonded to it. So it has the red group, orange, green, and white. So we can ask ourselves whether these 2 molecules that we've created are related to one another as enantiomers. In other words, are they non-superimposable mirror images, or are they totally the same structure? The way we can address that is by physically rotating around the molecules and seeing if we can totally superimpose all the atoms by doing that. If we can totally superimpose all the atoms by doing that, the 2 molecules are the same. If no matter how we rotate or turn the molecule around, we can't totally superimpose them, but we can make them mirror images, then the 2 molecules are related as enantiomers. So let's go ahead and do that for these 2 structures. So I'm gonna go ahead and try to match up, all right, red with red, green with green. Our orange and white don't match up here. So is there any way that we can make all the atoms match up if we rotate around? Nope, still doesn't match up. Match orange and white. Oh, now we've got some problems here where we can never make all the atoms totally align with one another, no matter how we rotate around the carbon-carbon bonds. Therefore, these 2 molecules must be related to one another as enantiomers. They are mirror images of one another, and if we line them up the correct way, we can see how they are mirror images of each other. Much like my hands are related as mirror images, these 2 structures are related as mirror images, where we have the orange atom pointed straight up, the green atoms are out to the left or out to the right, red atom is kind of back to the left or back to the right, and white is pointed forward in both cases. So these are related to one another as enantiomers. The only way to make these 2 molecules identical is to physically break a bond and put them in different places. So we can make these 2 molecules identical only if what I do is physically rip off by a chemical reaction, is the way we could think of this bond between carbon and the green atom, rip off the bond between carbon and the hydrogen, or the white atom here, and move those. So now that we've done that chemical process of breaking the bonds and remaking them, now what you will see is that these 2 molecules become identical, because when we put them side by side, we can totally superimpose all of the atoms that are the same color. So we have now these 2 molecules are related as identical structures. You may also have a molecular model kit that provides you with this type of atoms, the smaller atoms, smaller bonds, and this is a totally fine molecular model kit as well. You can assemble the molecules much like I have here to build you a molecular model of 2 enantiomers for this. And we can show that these 2 structures I've made here are also related as enantiomers because we can show that the 2 blue atoms are pointed toward one another. The white atoms, green atoms, and red atoms are all related as mirror images, just like my left hand and my right hand are related as mirror images of one another. And we can only change the relationship between these 2 molecules if we do a chemical process of taking the bonds, breaking them, and remaking them elsewhere. Otherwise, these 2 molecules are stuck forever as enantiomers, that special type of configurational isomer that refers to molecules that are related as non-superimposable mirror images.